In this video, we're going to be looking at algebra expressions. In the first question here, we have a to the power of p, a to the power of q, and a to the power of r. They're all multiplied. And Anne or Amy picked three values that were all the same. So we need to know our rules of indices here. When we're multiplying, we're actually adding the indices. So three numbers that add to give 12, and they're all the same, would have to be 4, 4, and 4. It could be a 1, and a 10. A 2, a 1, and a 9, and so on, which is part 2. Joe picked three values that were all different. So they're just testing your rules of indices, and you have to come up with the answer here, which is a new kind of thing that's going on in the junior cert. So I'll use 2, 3, add up to 5, which leaves 7 to give me 12, but there's many versions of this that are correct. Second example of algebra expressions is when we're giving values k is equal to 7 and m minus k is equal to 4, where we have to work out the value of 9k minus 6m. So if k is equal to 7 and m minus k equals 4, you should be able to see that m is equal to 11, or bring the 7 across. 4 plus 7, m is equal to 11, and you could just check it if you want. 11 minus 7 is 4. So 9k is 9 times 7, minus 6m is minus 6 times 11. Just calculator use, type in what you see. 63 minus 66 will be minus 3 for this first part. In the second part, 4-term factorization comes up every year. Which two are you going to pair together? I'm going to pair 1 and 3, the 8ax and the 4ay. So it's going to be 4a is the common factor, which leaves 2x to give 8ax, plus y to give 4ay. The shortcut to these ones is the second bracket has to be the same, or you can't do anything else. So what do I have to put in front of 2x plus y to get minus 14bx? Well, it's going to have to be 7 to give 14, and it's going to have to be b to give 14bx. So 7b, and it will be a minus because of the minus sign. And does minus 7b by plus y give minus 7by? You can see that it does. So finish it off, we have both 4a and minus 7b to be multiplied by 2x plus y. And then an algebraic fraction was the third part of this question. Multiply the two terms on the bottom, no matter what they are. 2x minus 1 by 3x minus 5. And then we start with this term and multiply it by this one. So 2 is not over 3x plus 5, so we multiply it by it. And then the minus sign, whatever sign is in the middle is important. We have 3 times 2, not 3, 2x plus 1. So we just remove the brackets on the top to get 6x minus 10, minus 6x minus 3, over 2x minus 1. By 3x minus 5, basic algebra simplifications. The 6x's cancel each other out to get minus 13 on top, and 2x minus 1 by 3x minus 5 on the bottom. The last part of this question, we're asked to solve this equation. So immediately you try to factorize it if you haven't read the question fully, but it does say correct at 2 decimal places. So the quadratic formula, which you all know off by heart, minus b plus or minus the square root of b squared minus 4ac all over 2a. Write down what a, b, and c are. A is equal to the coefficient of x squared, which you can see is 2. B is equal to minus 7, the coefficient of x, and c is equal to minus 3. So this is a calculator use question. You can write minus 7 into your calculator, or you could change that to plus 7. So we're going to use plus first, the square root of. Be careful to put the minus 7 in a bracket, or else just put positive 7 in. Minus 7 squared minus 4 times a times c, all divided by 2a. So fill your values in. 4ac is 2 and minus 3, and 2a in the bottom is 2 by 2. So this is just calculator use. Then we go back and we change the plus to a minus. Let's see what two answers we get. So the first one I'm getting is 7 plus the square root of 73, which you should see is 49, plus the 24, 73. 7 plus root 73 over 4. So you need to press SD in your calculator to give you the decimalized answer, which is 3.886, 3.886, and then it follows with a lot of zeros. So we're looking for 2 decimals. So 3.87 for the positive. Then just go back and change this one to a negative, to a minus. And we're going to get 7 minus, obviously, the square root of 73 over 4. And on a calculator, this gives minus 0.386 minus 0.386. Corrected 2 decimal places will be 39. So the quadratic formula used, the clues in the question, it will always say 2 decimal places or 3 decimal places. And from then on, pretty much write out your A, B, and C. Don't take shortcuts and use your calculator to help you get the answer. In this question, we have again substitution, 2p minus 1, 2p minus 1. If it helps you to set it up like this initially, by the square root of p squared. Anytime we're putting something in, put it in a bracket, plus 15. Check what p is, minus 7. So stick these values into your calculator and see what you come out with. Always check it twice. And there's nothing about decimals in this one, so you can see it's minus 15 on top, minus 14, minus 1, and on the bottom 49 plus 15 is inside the square root here, which is 64, and the square root of 64 works out evenly. This is equal to 1 7/8 minus 1.875 is minus 1 7/8, but we're not asked for that. Again, second example of a 4-term factorization. The first and last look obvious to put together. There's a 5f clearly inside both of them, which would leave h plus 3. Second bracket has to be h plus 3. So we want minus 2h squared here. So I have to put a minus 2h in front to get minus 2h squared, and we can check our answer. We should get a minus 6h for the other term, and you can see we have. So we have both 5f and minus 2h both to be multiplied by h plus 3. So no excuses really with your 4-term factorizations. Practice them. You can make them up by just creating 2 random brackets with any variables in them, multiply them out, and then refactorize it to get the same answer. You can see again the second example of an algebraic fraction. 2x plus 1 on the bottom and 4. Multiply the 2 terms in the bottom. This works every time. Cross multiply starting on the bottom right to the top left, or the other way around, top left to bottom right. The minus sign goes with the x, it's before the x, and that's times 2x plus 1. So what have we got on top? We have 4 5s are 20, minus 2x squared, minus x, and on the bottom we have 8x plus 4. So just tidy this up, minus 2x squared, minus x plus 20, over 8x plus 4 is as a single fraction. Sometimes in these questions you can factorize the top and the bottom and cancel, but in this case I can't see that you can. In this expression question we have the diagram below, 2 sides of a length of s. We can see them here. Now I'm going to create a full rectangle here, maybe with a better diagram. Just a straight line up and straight line across is a full rectangle. The area of the full one will be 10 by 6, which is 60. And the area of this box is s by s, this side by this side. So it's a square. So s times s is s squared. So the area of the whole shape is 60 minus s squared. I haven't read the question yet. You think I should? Find a formula for the area of the shape in terms of s. So that's what we have. 60 is the whole area. Take away the little box of s squared. And show that, or explain why. Well, in maths we'll always try and show, using mathematical knowledge, why the perimeter of this shape is always 32, no matter what the value of s. Okay, well let's have a look. We get rid of our diagram again. Just start from a blank diagram. You might draw it out again. So let's see what the perimeter is. So if this is s, this one here, the 2 pink lines have to add up to 6. So this is 6 minus s, this side along here. Similarly, I'll just change color to make it more visible. The 2 blues have to add up to 10. This one and this one have to add up to 10. So we already have an s there, so 10 minus s will be this one. And if you put 10 minus s and s together, you can see they add up to 10. And if we put 6 minus s and s together, they add up to 6. So it doesn't matter what the value of s is. These lengths will always be 10 minus s. So let's look at the perimeter. 10 plus 6 plus the 10 minus s that's here, plus this s plus this s. You can see what's going to happen with the s's. Plus this one is the perimeter of the shape. So I have an s and a minus s, an s and a minus s. 10, 20, and 12 is equal to 32. So that's showing it mathematically. So you could say the s's will always cancel with 10 minus s and 6 minus s, but if you show this mathematically, there will be no need to do anything else. More factorizations. You should be able to identify that this is the difference of two squares. We have a to be squared minus 4n to be squared. So what you might have learned is x plus y by x minus y. Or it's the same thing in both brackets. One's a plus and one's a minus is the way I would have described it to my students when we can identify the difference of two squares. And if we multiply this out, a by a is a squared. Then we have a by plus 4n, which is 4an. And when we have same thing in both brackets, the middle two terms will always cancel because the signs are different. Minus 4an, you can see this is equal to 0. And then we have minus 16n squared, just to verify your answer. So difference of two squares is the easiest question you will ever get if you have spent the time dedicating to getting some of this knowledge into your head before you go into the exam. One of the factors of this term is x plus 6. So the easy way to do this is to say x plus 6 by something has to give 8x squared. Well, it would have to be 8x here to give 8x squared. And minus 18, this would have to be minus 3 to give minus 18. And then we can check our answer. So we would have 8x squared with the first term, x by 8x. X by minus 3 is minus 3x. This one by this one. Then we have 6 by 8x, which is plus 48x. And we've already done 6 by minus 3, minus 18. So you can see the middle two terms are 45x, which is what we have up here. So we have factorized it now, but they're just trying to really confuse you with the information given that one of the factors of is. You should be able to identify that we can really come up with this quickly. We could use the box method of long division, but this works much better. Now there's one other quadratic expression in x other than 8x squared plus 45x squared that has x plus 6 as a factor. And we're asked to write the answer in the form ax squared plus bx plus c. So all they're asking you to do here is take any term and multiply it by x plus 6. If I multiply x plus 6 by x, the easiest one is just x plus 1, x squared plus 6x plus 1x if you want to write it out the long way. Plus 6 would be x squared plus 7x plus 6. That's just one possible answer out of an infinite number of answers. Any term that multiplies by x plus 6, if you have an x and a number, will give an expression in this form, as you all know at this point. In this question, we're asked to show something is a factor. This linear expression, which is y or x to the power of 1, is a factor of a cubic expression. And anyone that has ever sat in my class knows I am obsessed with the box method. Easiest way to divide linear into cubics or quadratics into cubics, whatever we want. My linear, 2y and the plus 3 goes on the outside of the box, and the first term and the last term of the cubic go in these boxes here. The expression that we end up with on top in this position, and this position will be a quadratic. So let's see how this works. You all know at this point. 2y multiplied by this term gives 2y cubed. So this will be a y. And then this box here is y, the y on top by the plus 3 on the outside, which is plus 3y. This box, maybe over explaining, but if you haven't seen this before, maybe this will help. This box is 2y multiplied by something gives what's in this box here. on the inside. So how many y's do we have? Sorry, this is y squared here. Y squared, my apologies, 2y squared, and this is 3y squared. I'm Russian. So how many y squareds do we want? We want minus 9y squared. We already have plus 3y squared in this box here, so we need another minus 12y squared inside the box to give us 9y squared, or minus 9y squared. And then this box on top multiplied by 2y gives minus 12y squared, so this has to be minus 6y. For 2y by minus 6y is minus 12y squared. And then this box at the bottom is minus 6y, the one on top, by the 3 on the outside, minus 18y. And how many y's do we want? These two boxes are my y's. We want minus 28, so this has to be minus 10y because we've minus 18 in there already. And 2y, this 2y again, by something, this one on top, gives minus 10y, which will be minus 5. And we can always check our answer, and this is how we show it's a factor. Is the minus 5 that we've just drawn by the plus 3, is that equal to minus 15? And it is. Minus 5 by plus 3 equals minus 15. Therefore, what we would say here, no remainder. If it doesn't divide in evenly, there will be a remainder, or these two things won't multiply to give the last number. No remainder. Therefore, 2y plus 3 is a factor. So, box method of long division, if it comes up and you know how to do it, it's a really easy question. There is another way to do it, which I'll do as well, just it's a visual thing, but we see exactly the same numbers that we do inside the box. So I'll just reset it. So 2y plus 3 by something. Now, if you know your maths, it has to be 3 terms, gives the cubic. So what would have to go in position 1 here in the second box? It would have to be y squared. So you can see I get my 2y cubed. Now I already have, now I have 3y squared inside. I want minus 9y squared. And I want minus 15. So I have to have a minus 5 at the end to give me minus 15. I'm just going to write 3y squared beside this one. Here I have minus 10y. We want minus 28. And here I have my minus 15, this blue line. So let's just look at the red lines. The middle term, this red line going to whatever's in the middle here is a y. We have a y squared, a y, and a number. And I have already got 3y squared. So to get minus 9y squared, which is in the expression up here, we need to have 3y squared minus 12y squared. So 2y, the term at the beginning here, multiplied by something gives minus 12y squared. Well, there's 6y would give 12y squared, so minus 6y. So this term has to be minus 6y for it to work. And then we can check our answer. We can say this 3 by this 6y is minus 18y. You can see here minus 18y and minus 10y is minus 28y, which is in the question. So they're the same numbers from the box, but just a kind of messier way of looking at them. So practice these algebraic expression questions and master the factorizations, 3 terms, 4 terms, linears, cubics, all that kind of stuff.